All right. Hey, everyone. Hopefully by my color scheme, it shouldn't be too obvious when I started working on these slides. So, my name is Bryson Tyrrell. I am a desktop services specialist with Jamf Software. So I'm internal IT at Jamf. And if you ask people around the conference who know me, they would actually just say that I'm their Casper guy. Because that's pretty much what I do internally. I'm the Casper admin at Jamf Software, working with a few other people on the IT staff. Want to just shout out here to Jason Miller, because I forgot my clicker. I like to free roam and wave my hands a whole lot, so he lent me his. Right there, Twitter, Slack, LinkedIn, those are all the places that you can find me out there on the web. So if you need to reach out after the conference, that's where to do it. Just going to say this here. You don't need to take notes. There's nothing to take notes about because everything that you see in here, plus a few extras, is out in this GitHub repo. And if you haven't gone out and grabbed all this stuff yet, thankfully, Python files at GitHub are really small, so I think the AT&T Wi-Fi will hold up if you go out to just download it right now. All right. And then if you need to run the examples, just use that syntax right there on the files from your terminal. Okay, so we are here today to talk about Tkinter, Python and Tkinter. That is the title of this deck. There we go, Python Tkinter. Got to remember to click this thing. And then really this is all about adding yet another tool to your knowledge arsenal. A couple of things that we're not going to be talking about here is convincing you that you should just use this all the time. It's not the point of this. This is just about sharing knowledge and giving you yet another option for when you have to come up across something. And it's definitely not about telling you that you shouldn't use Cocodialog anymore or Jamf Helper if you use Jamf Helper. All right. Ooh. Okay. There we go. So Tkinter is not a part of Python. Tkinter is a toolkit. It's a cross-platform toolkit. It works on Mac, it works on Windows, it works on Linux. And it actually interfaces directly with the window managers of those operating systems. So if you import the library into Python and you're writing Tkinter code, that code, with a few exceptions here and there, will work across platforms. It's actually really, really widely used in the scientific community. Data mining in the scientific community, they build GUI applications around that stuff for visualization and interaction, and this is the primary GUI toolkit that they use for that. That's where you see it the most. One of the great things about this is that Python and Tkinter are standard on Mac OS. So, if you have a Mac in front of you, they're preloaded by Apple already. So, this is a solution where you can run a script and execute code on a machine, and you don't have to pre-install or pre-configure anything. It's just there. And it also means that if you were to build out a script that popped up a GUI for the user to do something with, what you take away from their interaction with that dialog can be executed within the same file, also in Python. So you're keeping it all in one language and in one file/program. And the other thing that some people don't really think about this too often, but the other thing is that with a lot of other solutions, the user clicks on something, and the GUI closes, and it returns something, and then you either have to parse what was returned, or you have to grab the exit code and then build logic after that, and maybe you have to represent a GUI to them. But going this route, you don't have to have the GUI close until you wanted to, which means they could click on something, and what they clicked on is not what you wanted them to do because they didn't do something else already, and you can give them feedback without closing the window. So it really comes down to a lot of user experience sort of crafting when it comes to going down this route. There's a lot of things you can control when it comes to the user experience. This was asked in the hall, and I was actually going to bring it up anyway, but I just want to show of hands. Is there anyone in here not familiar with Python? Okay. Is there anyone in this room, because I'm going to make a reference to something called class inheritance at some point in this presentation. Who here doesn't know, you don't have to understand it, but who here doesn't know what class inheritance is? All right, I am sorry. But I'm not going to be getting into the deep internals of Python, and I am walking through a lot of code in this, but I'm walking through it. And we aren't going to talk about class inheritance. I'm just going to make a reference to it when you see something on the slides here. This stuff should be pretty easy to follow along with, but a working knowledge of Python probably is something that you do need. All right, so Tkinter, GUI toolkit. What exactly comes with this if you're planning to build out some sort of interactive dialogue for end users? And the thing is, it actually comes with a lot of options. So in the upper left-hand corner there, I'm going to use a little laser pointer here because it's fun. So right there, those are standard entry boxes. We see them in like OSA script pop-ups all the time. Cocodialog does them. Just like Cocodialog, on one of those entry boxes, you can have it replace characters that get typed with something else, like the asterisk. So you have a secure text entry field option. Right next to that, that is a combo box. And so it acts just like a drop-down option menu, except you can actually have users edit the contents of it and add and remove things. And then you can return that as a list. Next to that, yet again, we have radio buttons. And radio buttons group together, and you can have multiple groups on a single GUI if you really want to, but it means that they have to pick from one of the available visible options. In that example right there and the one below it, really what it is you select one of the radio buttons and it changes the color on the background. And in that example, it's just to show you that it's doing something. Next to that is list boxes. And list boxes are also extremely flexible with Tkinter because in this example, it's a single selection list box. But it also supports a multi-selection where you pick one and then you pick everything below or above it that you want, or multi-selection where you actually hold down Control or Command and then individually pick what you want. And then you can go and grab, as a tuple, everything that they selected. Next door to that thing is the option menu. It's just a drop-down menu. Same thing as with my example on the choices. It's just got a color picker, and it just changes the color to show you that it does something after you make a selection. And then this last one right here is loading bars. And loading bars is actually something I see people ask about here and there because it's mostly with Cocodialog, because Cocodialog does present a progress bar option for if you want someone to have feedback that something is happening in the background. So there are actually two options there. The indeterminate progress bar, that is the style where you click on something and OS 10 pops up a loading bar dialog and you just see like that sort of a shaded white area passing over the blue. You know, it just does that if you load that up and start it. The determinate progress bar has two different options. You can load it up and start it and it'll just endlessly keep filling up that blue bar, or you can actually define a value for it and you can increment that value however you want, and then it will actually progress according to what you're doing in your code. Now, all these things individually, sure, fine, that's great. It has all these options, but there's not a whole lot of value in popping up one window that has an option menu, and then there's nothing else there. Where a lot of the strength comes in here is when you magically merge everything together like Voltron, and it just gets better. So this window right here is actually just, doesn't have any code changes from all the other ones. It's actually just merging all the code from all those different examples, gridded out into one window. And I'll explain gridding in a little bit here. So the file that's in the GitHub repo is called Tkinter widget examples. You just need to run the file, and then you'll get a whole smattering of windows populating up on your screen. There's a root one that says close this one when you're done. It'll close all the others. All right, and then if you go through that example code, several of them make use of something which we'll walk through a little bit later, which involves storing what you see on the screen in a variable so that you can manipulate the contents on screen or call it out later. And then the other thing that I wanted to call out here was that the combo boxes, list boxes, and option menus can all be dynamically populated. You don't have to hard code that stuff. You can pass things into it or have it collect data from somewhere else, and then it'll populate those options when the window loads. And in some cases, you can actually change the contents of those option boxes and list boxes and whatever as the program is running. So that actually leads to a lot of crazy little things that you can do that just pop up for the end user for them to interact with something. This here is One such example of that, in self-service, when somebody wants a new iPhone, they open it up, they click on order an iPhone, it pops this up, then after they make all their selections of what they want, it creates a ticket to order it. And this is all being dynamically populated in the program when it runs. It actually pulls down data from somewhere else. And all those list box options, you can see that the contents are actually changing as I scroll around here, because we say that you get $300 towards an iPhone. So there's actually a JSON type listing that's inside there, which says which model is okay, which storage amounts are okay, and which colors are okay. And in our case, we don't really care, so all the color options are there, and they just point to a URL where it goes and grabs the image that's showing. So that's a complex example, because you can see it's using a lot of different features of the language and of the GUI toolkit all at once. So we're going to get started here, and I just need to make a quick note of something in case you're already browsing the code, and that's Tkinter and TTK, because you might see TTK getting imported in there. And Tkinter is the base library. It contains the class that's going to be the root object. You always need to use this. This is how you generate or initialize the application. It also has all the base widgets that we're going to be using. TTK is an add-on, and it actually has several versions of those widgets that are better themed for the operating system. And with very few exceptions here, everything's going to be just shown using the standard Tkinter version of the widget, but there is one exception to that, which I'll call out later. All right, so what we're going to do here is we're going to create a boilerplate. And the boilerplate is a basic template from which we can then copy and paste it into a new project to get started, so we don't have to keep redoing a bunch of stuff to get our base window code. And yes, there is a bit of code with Tkinter. It doesn't just work right out of the box. It does require some setup. You know, it's not quite on the same level as building an application in Xcode, but there is some code to do this, and we're going to actually walk through the code so you can better understand it. And yeah, basic template, and we're going to do a walkthrough. All right, so first up is the basic and the ugly. And kind of just what we want to do for the base window that we'll build upon is to get something that looks approximate to what the standard OS X dialog looks like. You know, same gray background, buttons look similar, similarly placed. You know, we're going to use this as the basis for what our boiler code should generate if you were to just straight up run it. And just to go back to the whole thing about how Tkinter works across platforms, like on the top and the bottom here, we have Mavericks on the top, El Capitan on the bottom, and that's because when you can take the same Tkinter code from one version of OS X to another, and it will theme itself more closely to that version, so that the way the buttons and all the other elements look like they belong on that version of the operating system. All right, so basic and ugly. And this is the #1 thing that people hate about Tkinter when they go try it for the first time, and that is that there is a white background that doesn't look like it belongs in OS X. It looks even worse when you actually start populating stuff in there and you have a big, ugly white window populating it. We're going to get to that in a moment, though. On the left here, this is the basis. This is as basic. You can actually get way more basic than this for a Tkinter application, but this is a template that I've sort of settled on for this. In the main function, we're going to be creating the root of the application. You can see at the top there, I'm importing Tkinter as TK. You'll see that in examples all over the web because it gets really, really frustrating to type Tkinter for everything that you want to use. But at the same time, I will call out that you'll see a lot of examples where they'll say from Tkinter import star, which means it just imports all the classes as their own names. Don't do that in any of your Python code unless that is how the library is designed. It makes your code really hard to read, and other people don't like it. So if you need to shorthand it, use this method. And technically that's incorrect because I'm taking a camel case class and I'm doing it as TK. If I were to throw this through Pylint, you know, it would scream at me for doing that. Anyway, I digress. tk.tk, that right there, that is the root application. That is how you start this every single time. This chunk of code right here, This is that reference to class inheritance that I'm going to make just once. A frame, you see up there where it says app and then parenthesis TK frame. A frame is a type of container for Tkinter. So what we're actually doing is we're creating a class which is a frame, and so it's going to inherit everything that the frame does, and then we're going to build stuff into it more easily. So I'm not really going to get into this because, sometimes when you're looking at examples of class inheritance, you'll see a call to something called super, and otherwise you'll see syntax like I'm using here where I'm actually calling TK frame and its init method and passing stuff into it. Just go get a quick tutorial about Python classes to just get the basics, because this is really just the basics about classes right here. And it's not really overly complicated. It's when you get into other things you can do with class inheritance or multi-inheritance that it gets complicated, and we're not touching any of that stuff today, so you don't have to worry. The big important pieces here is right away, I'm calling something called pack. So self. Self means I'm referencing the class that I'm in, and I'm telling it to pack itself. It's a frame. It's a widget. All the widgets in Tkinter, you have to place them in your GUI. And there are 3 different methods for that. The easiest is pack. And what pack does is you call pack on a widget that you just typed in, and it will place it in sequential order in the GUI top to bottom. And there's some other methods for tweaking that, which you'll see in a minute here, but that's the basic gist of it. Grid we'll explain a little bit later. Place, I never use. And I'm sure that there is actually some really good use cases for it, but place means that you actually give it X, Y pixel coordinates, and you tell it it always goes there. Don't use that. You'll be very sad trying to make that all work together and keep it floating in the right position. If you're using place, you can overlap elements. If you're using pack, you can't overlap elements. If you start mixing and matching pack and grid, bad things can happen. We'll cover that. Don't mix pack and grid or else you're going to have a bad time. So then right after that, you see there we're calling the master. The master is our root object. So as you can see down there in the main function, app equals, and we're calling our class, and we're passing the root into it. In Tkinter, every time you create a widget, it has to have a parent. In this case, our frame where all the stuff is actually contained within it that gets displayed on the screen, the parent of the frame is our root application. The label in there, we're saying self as the first argument. The first argument is always the parent or the master. So in this case, we're saying that label belongs to the frame, so that way it packs the label inside the frame. And this is a shortcut here because since we're not doing anything, we're just showing text on the screen, it's just one line. We're calling TK label, telling it what we want it to say, and then we're just packing it right away. And this code here is the basis for what you see on the right-hand side there. The Mavericks one only looks a little pixelated because I was doing that in a virtual machine, whereas the other one I was just doing on my main desktop. But you'll see that it's actually using the system fault for that version of OS X by default. You don't have to do anything weird or fancy to get San Francisco to display. All right, so here we're going to start doing some things to start controlling the basic appearance here, because the ultimate goal of this is that we want to present dialogues that look like they belong to OS X to our users so it blends nicely. So first things first here, you'll see that we've got this new thing that we added into it, master resizable, and we're passing false false. We're passing false twice because you can make this independent. You could allow them to resize it on the X or Y axis independently. And here we're telling it that they can't do it to either. So whatever the window ends up as for a size after we put all of our content into it, it's going to stay that size and they can't resize it. And you can see that on the right-hand side, the green button for maximizing the window is now grayed out. Oh, one thing I forgot to mention is that you see those 3, you kind of do. I didn't think it would be this dark when I chose this color scheme. But those 3 dots that you're seeing throughout there, this is the walkthrough part. So the dots say that there was code there in front or above or behind this thing. This is just all the new stuff. So we're not showing any of the code from the previous slide. All right, so now we have TK palette. And what the palette is on the master, we're actually setting what the background color is. And we're telling it it's going to be this shade of gray, which matches El Capitan's shade of gray. And if you wanted to look just a little bit different and then more accurately match across versions of OS X, the hex code for that is actually E6, E6, E6. Semantics, whatever. It's gray. That's the important thing. See, it's gray. It's what we want. We want a gray background. This chunk of code right here is also something where you can actually have some fun if you're building GUIs this way, because this chunk of code right here is calculating the X and Y values for where we're going to have the window draw on the display. In this case, what the code here is doing is it's calculating the center of the screen horizontally and 1/3 from the top down for the Y. So it's centered but slightly elevated, which to me just works better because people's eye level is usually a little bit higher than just the direct center of the screen. Now this is just calculating that. The thing is, you can pass into this geometry method any coordinates you want. You can draw your windows anywhere on the screen with precision that's relative to the screen size. And this code can be a good starting point for that. In this case though, in my boilerplate, I always have it drawing that window sort of upper center. And then right here, this is also something which is, it's optional later on. What this is doing right now is Tkinter, of course, it talks to the window manager and says, I want to make a GUI. Well, when you make a GUI, just by default, there's going to be a blank Python menu option across the top of the screen when you have the window selected. You get rid of that by passing an empty Tkinter menu widget into it. You know, there's nothing in that widget. I'm just creating an empty menu widget that the master is the parent of, and then I am passing it into the config for it. Menu equals a blank menu. So now when this GUI fires up and you click on it, there's no menu bar option. It doesn't say Python with no options or anything like that. That is just a user experience thing, because we're not going to have file, edit, view menus for this little GUI. And this last thing is a bit of a hack. I'm going to admit that. There is an unfortunate thing about using this method with Tkinter, and that is that your GUIs do not come to the front of the window stack by default. Now, there actually is a configuration change that you can make on the root inside Tkinter, which will bring it to the front. But that won't make it active. It'll just bring the window to the front, but they still have to click on the window to make it the active window. This here calls some quick Apple script to bring the window for the Python process all the way to the front. And that makes it the active window at the same time. In addition to that, you also don't have to use subprocess for that. If you want to get into it, and for anyone who isn't quite aware of what's going on there, subprocess is actually calling OSA script, and it's telling the finder, bring Python to the front. You could do the same thing by importing from Foundation NS Apple script, and then passing the string into NS Apple script, and then calling that, which is a bit more native because you're not shelling out. Both methods work. This is one line. Fits better on my slides, so I chose that. All right, so here, we need to get into some better stuff here. So, buttons. We need buttons. You have no limit on the number of buttons you can have on a window in Tkinter. You could make a 16 by 16 grid of buttons and tell the user to pick one. And then they don't know what will happen. It's like the mystery box. So, this code right here, these are our buttons. TK button. We're telling it the text that we want to say. The text can be whatever you want. I haven't tried it yet, but I believe emoji will work for this too, if you really want to try it. You'll see that on the top one, the OK one, I have an extra keyword for active. That's what's highlighting the button blue. So when the GUI comes up, the OK button is the default button, and it's blue. That's the only difference there. Lots of widgets actually support that default keyword. You just have to go look through the docs of them to see what they do or don't support, because keywords are shared across a lot of them. I'll point you to the documentation for a lot of these things later. The other thing that you'll notice is that I'm doing this thing with pack where I'm saying side right. So this is where you can somewhat customize how the pack method works. In this case, when you call pack by itself, like I said, it does it sequentially. Top down, it'll pack your widgets. When you add a side in there, I'm packing the label from earlier in our code, so that's at the top. But now on the next line where it would pack the next widget, I'm saying side right, so it actually aligns it to the right. But then if the widget right after that, I say side right again, it packs that one on top of that going right, so we actually end up with a line of them. That can get messy later on if you're trying to do a whole bunch of widgets, but on our next slide, we're actually going to cover how to organize that. The other great thing here is this, the command keyword. And you'll see that I'm actually pointing it to these click methods. Because in a class, you can have a class have its own functions. They're called methods. And there's no parenthesis after that, because if you add parenthesis, then that means it's trying to execute the code as Python is reading through it. No, you're just pointing it to your functions down there. And what this does is when they click on that button, that means it goes to execute the code for the function that you're pointing to with the command keyword. And you can have it do whatever you want. You'll notice that on the OK one, I'm just having it say print, the user clicked OK. On the cancel one, which I forgot to add a box drop for, you'll see self master destroy. That closes the GUI. So you can actually do whatever you want without closing the window until you call self master destroy. Until you kill off the root of the application, it can stay open and you can keep doing things. You don't have to have the dialog close to start executing the actions that they wanted to perform. All right, so here is where we get into the organization, and this is where things will start making more sense. And you're going to notice something on here in a little bit, because a little bit ago I said don't mix and match grid and pack or else you'll have a bad time. Or is that a little early? That's a little early. I'm not using grid yet, so disregard that just now. So up here, just talking about again how our class, the main container for all of our stuff is a frame. Well, now we're actually adding in more frames where this frame is the parent. So you kind of see what's going on here now? Because we have the dialog frame, but we also have the button frame. And I'm also doing some new things with pack here again, where I'm actually adding padding onto it. I have different padding on the y-axis than I do on the x-axis, and then when I pack things inside that frame, they just sort of inherit that extra padding around them. So you can see on the right-hand side there that there's space around the label widget now, and there's space around the buttons because the buttons are off in their own, they're off in their own frame as well. Okay, read that a little bit there. Right. So the other thing about the button frame, though, is I'm telling it to anchor to the right, because I have to tell that it's right justified, because when I'm packing widgets in there, they'll end up centering themselves, even though they're aligned to the right, because I've moved them from the main frame into a subframe. Now, this might seem complicated until you can make a comparison to something else. Who here plays with HTML? Who here knows what a div is? Does this feel kind of similar to how a div works? You put divs inside divs inside divs inside divs inside other divs, which are subclasses of something in Bootstrap, and you don't even know what your code looks like anymore. But like this is the same exact concept. Frames are kind of the HTML equivalent of divs. You make a frame, you put stuff in it. You make a div, you put stuff in it. And it helps organize the contents of what you see on the screen. So we're actually almost done here, and we're just going to add a few final touches. The first thing is this is all user experience stuff, and this actually also goes back to some of the strengths that we have with Tkinter. And what you see right here is this master protocol. The protocol, WM window delete. If you see anything in Tkinter examples that has WM in it, that stands for window manager, which means the operating system. We are overriding what the operating system will do when a user clicks that little red close button. So what we're doing is we're saying if they click that little red close button, call our cancel function, which means that we retain control over what they're trying to do with the window. They can't just close out of it without it still going through our code to have us make sure that they did what they were supposed to do. And this is also where you can have a whole lot more fun because, unlike with some other solutions, you can bind keyboard keys to specific functions. So in the boilerplate example, by default, I want to say if they hit the return key while the dialog is open, it's going to trigger my OK function. So it's the same exact result as if they had clicked OK. If they hit the escape key, it'll trigger my cancel function, so it's the same exact thing as if they had clicked OK. And you can do this with any number of keys or key combinations. You can create bindings, so that way you can sort of give it a better user experience because they can more natively just interact with the keyboard and the dialog like they can with other native windows. Then we got this at the bottom here. And this took a while, and I eventually found the code somewhere inside Monkey's code base. So when you're firing off these Tkinter dialogs, you'll notice that this Python rocket ship thing appears in the dock. That's because the code's being executed through the Python launcher, and when you open up something on the Mac, the icon for that has to appear in the dock, so you get this funny little icon nobody understands. Like, what is that? Why did that just pop up on my dock? Using the Objective-C frameworks, you can do this in a different one besides AppKit. Does anyone know where else? I think it's Foundation. NS bundles in Foundation. Yes. Same damn thing. But in my case, I call AppKit. What you can do is before you call root equals tk.tk, before you do that, you can load the info-p list for the Python launcher because you're currently inside Python, and you can dynamically flip the ls_ui element value to true, which will tell it there should be no dock icon when this application runs, which means we now have an application where we have key bindings. We're controlling how they close the application. It looks like it belongs on OS X, and it comes to the front, and it also doesn't show stuff in the menu bar or the dock. Yes, that was a lot of code just to get to that point. But now we're going to get into the stuff that involves you actually building out really cool experiences for your end users. It's example time. So I built 2 examples for this presentation, and we're going to walk through all the code in those examples. And you can actually also pull those examples up in the GitHub repo. Number 1, the one thing that everybody always wants, a password prompt that actually has 2 fields for entering in their username and their password without having to do one dialog saying enter your username. Next dialog, enter your password. You don't have to do that. I know Cocoa Dialog has this, but you can roll your own. And at the same time, back to that whole thing where the dialog, this window doesn't have to close until you're ready for it to close. You can also further customize this even more. But as a base script here, we're going to go through some of the things in this code, which are, again, this is built on top of our boilerplate, so I'm only showing the changes I made in the code, from our boilerplate. This is a new kind of widget, message. Message is a little different from a label because a message will auto-wrap text by default. If you see in here, there's a few things that I'm doing here. I'm telling it to be left justified. I got my string of text up there. There's also something else that's sort of interesting here, and that's this little piece right here, font. They're actually, because Tkinter is great for consistency, there are actually 2 different ways to change font values on widgets. You could actually do a whole bunch of different stuff on the screen all at the same time. Sort of like when the original Mac supported multiple fonts. People went crazy with that. But in this case, I'm actually just passing a string, and the string is just the font I want, the size I want, and then the style that I want. And Tkinter just parses that, and that's why on the previous slide you saw it was in bold and slightly bigger font at the top saying, please enter your username and password. Tuples also work for this, and you'll see an example of a tuple version of this later. All right, continuing on with the code. I told you there was a lot of code in this presentation. Don't lose it now, but we're doing something different now. So in the first example, where I just showed you an entry box, or just any of the widgets that we were doing so far, we haven't been assigning them anything. We've just been putting them in the code. One line, here's a widget, packet, all on one line. Here, we're doing something a little different. We're assigning it to a class attribute. And if you're a little fuzzy on the class attributes, they're just variables that are tied to a class. Self dot the variable's name, so that means it's tied to that class. So I'm actually assigning the entry box to one of those things. And the reason why we're doing that is because we want to be able to extract those values that they input in the entry boxes, which means, I am going down the rabbit hole a little bit here. So there's this little thing called scope in Python. The thing is, when you go to call another method inside a class, like our click OK function, if you weren't to assign these things to a class variable and they were just to their own variables, it has no way of actually going outside of its box to get those values. You have to assign them something in the class so that you can actually just say self, referencing the class, and then the name of the variable that you want, variable or other object that you want to interact with. That's what we're doing here. So we're actually making the entry box assigned to this class attribute. But you also notice that we don't have the pack on the same line. The pack is actually on the second line. And this is a gotcha. When you call pack on the same line as the widget, Python always returns something. So when you call it on one line like that above, where it's the TK entry box, it returns the TK entry box. If you call pack right after that, well, first it creates the entry box, and then it does pack. So it returns the very last thing it executes on the line. Pack returns none. So you would end up with an empty value, and you can't do anything with it. So you have to call pack on a separate line if you're assigning it to something to interact with later. This also is another little user experience thing. Focus set. I'm telling this new entry box that it's going to take focus when the window loads. That means that when it opens up, it's going to be highlighted with the blue box and ready for them to type text into right away. And in that example from the TK widgets examples file, where it was the entry box that hid what you were typing in, it's that keyword right there, the show keyword. That does the magic. And you can replace that with other ones too. You can put a hashtag in there, whatever. Example number 2. And that example is our file uploader. And I have this split across 3 windows here because this thing does a lot of stuff. And this one we're going to spend a lot more time on. And I'll show you the actual application working at the end of this. But this one takes tons of what we're doing with all this stuff up to now and actually combines it together. And it makes use of a few new things. So we're going to go through some of this code right here. And here's one big thing right here. The string var. Another gotcha with Tkinter in Python. Tkinter can't just use the standard variable types because it's not really a Python library. It's a toolkit that Python interfaces with. It's got its own set of variable types that it uses. So we're creating a class attribute here for file count, and we're making that a string var. And we're giving it an initial value of blank. Then over here, the label. We're creating a label right next to our button, except this label does not have any text. We're actually assigning that variable to the text variable. So, cool thing about Tkinter is the fact that you can dynamically change what's being shown on the screen by using things like variables assigned in place of text. So instead of hard coding the text, you can make it point to a variable, and then at any time in your code, you can change the contents of that variable and it'll display on the screen. So you could actually give real-time message feedback to users as your code's executing after they click on something. So down here, there's a lot more going on here because you saw the text box in the screenshots there. That's a text widget. And it's literally, as it sounds, it's a big text box for them to enter in a large comment or anything else. And it actually is really, really powerful in what you can do with it. I have not gone very far into any of that stuff because I've only ever used it just for entering in a comment that's going to go with a ticket or something like that. Pretty basic. For appearances, because if you just draw a text widget onto the screen, it's a flat white box or a flat gray box, or it doesn't look right. What we're actually doing here is I'm creating a frame for it, and that frame actually is using see up there in the upper right there, it says relief sunken. The relief is a sort of an embossing attribute for a widget. You know, sunken right here means it looks like it's depressed into the screen a little bit. You can also do raised, so it looks like it's popping out, you know, things like that. And it's just a visual element because throughout OS X, normally when you're interacting with a text field like that, it looks like it's depressed into the screen a little bit. So in order to get that appearance, the frame is actually doing all that. And then we're packing the text box into the frame. You also notice that I've also got a few other things going on here with the colors for it. That is all just to make it look much more OS X-y. So it's got the right kind of blue. It's white background. Because if you remember earlier in our code, we set it so that all of our widgets would have the correct gray background. So we're now overriding that for this widget. And then this is where you see that example I was talking about of the tuple method of updating the font. I'm passing just two values because I don't want to add emphasis onto the text they type in, but it's system font size 14 is what they'll get when they start typing into the text field. Once again, you'll see focus set at the bottom there so that when this window opens up for the first time, the text field is where the focus is, so they could start typing something right away. And then we pack it all. Now, you notice in one of those screenshots, I actually had a file chooser overlaid on top of the window. This is where some cool stuff can be done with Tkinter and also where it can get really frustrating. So there is a set of dialog classes available as separate items for Tkinter. And the one that we're using is TK-FileDialog. And it's not just simply calling a file chooser. There are actually 6 or 7 different file chooser options to do because they will all do different things depending upon what you need. The one that I'm calling right here, once again, I got to remember to click through my slides. So the one that I'm calling right here is ask open file names. Not ask open files, ask open file names. This particular one allows the user to multi-select files from that pop-up window, but it doesn't open the files, it returns the paths to all those files. There are circumstances where maybe you just want the paths to the files they chose. The other option to this is ask open file name because you're restricting them to just one file name. There's also ask open file and ask open files, and when you choose those ones, you get the file objects returned automatically, so you don't have to go open them later, but you do have to close them. So there are a lot of options there, and I'll show you how we interact with the file paths when we get to our submit function. So I'm going to take a moment here to go outside this, though, because I mentioned that there were a number of TK dialog options. There's also TK color chooser. I have no idea why we would need a user to pick a color, but it's there, you know. The other big one is TK message box. And TK message box is awesome and infuriating at the same time. So the one thing that you remember from that screenshot was that this dialog was overlaid on top of our parent window. That's because if you pass to it parent instead of a master keyword and you're telling it who the master is, you know, we could just pass our root object to that, and it would be the master and it'd be assigned to it, but then it would be an independent dialog box. When you use this parent keyword, the dialog classes will actually render as sheet styles. You can't do that anywhere else in Tkinter, and I don't understand why. I can't create my own window class and have it render as a sheet on top of another window. And if you aren't familiar with it, the sheet is when you click on something and it sort of draws out the window from the top of your current window, like with preferences or something, and then it just sucks back up again when you're done. It's a really cool visual effect, but only these dialog classes can do it, and it's not in the rest of the standard Tkinter library. I spent a week trying to figure that out, and I eventually threw something against the wall and gave up. The reason why I say that's infuriating is because the TK message box class allows you to do things like really quick yes/no prompts, warning prompts, info prompts, question prompts, the standard OS X dialogues, and they can render as sheets around the window. And you have to dismiss them before you go back to the main window. It's really nice. They show the application's icon in those dialogues when you call them, which in our case is a rocket ship with a Python wrapped around it. It's really not that elegant. Now, if you were writing a standalone application you were going to deploy to OS X, you wrapped it up in Py to app, and you gave it its own icon, it would show that icon. It would look great, and it wouldn't be a problem. But that's not what the point of this session is. The point is that we can run dialogues from a script without preloading anything. So those dialogue options are really cool, but at the same time, you get a Python with a rocket ship on them when you call them. Now that doesn't happen with the file dialog because it's not showing anything on the screen except your file chooser. So your mileage may vary if you actually want to make use of one of those. The syntax is identical to this. You just call the class and you call the type of dialog prompt you want, and then you pass parent to it instead of assigning a master, and then it'll render as a sheet style. And I do recommend when we get to the end and I got the doc links that you go check out the docs for these things. All right, so next chunk of code. There's a really, really great thing that you can do, which again is all about controlling the user experience, because we actually have a pop-up overlay I'm about to show after this. But if we have a pop-up overlay, we don't want them doing anything on the main window while that's happening. So just like you can have dynamic text changes and whatnot with widgets in Python, you can also dynamically disable them and re-enable them. So this little class right here is actually doing that. If you want to make a widget disabled so it's grayed out in the interface, you actually just call this configure method on it. You say state equals either disabled or normal. Again, consistency, because enable doesn't make sense, but normal makes sense. So right up here, this is just for me because I copy and paste this code around in some of my stuff sometimes. I just make it dummy proof because sometimes I forget. So with the state attribute, it can only ever be normal or disabled. So pretty much when I call this little function, I just tell it whether or not I want the widgets that are listed with it to be enabled or disabled, or normal or disabled. And right here in a tuple, I actually give it all the widgets that I want it to operate on. So we're disabling our buttons, we're disabling the text field. And actually, yeah, for this one, that's why. And also the label. We're disabling the file label as well. So they all get grayed out in the background when our little pop-up widget occurs. And then we just loop through them one by one, and we configure them. So after I disable them, when I'm done with whatever it is I'm doing, I call this method again, and I say normal, and then it will re-enable all those buttons. I should actually say, go back here. This can actually be made even much more dynamic because you could actually pull out a list or a tuple of all the widgets that belong to a parent object. So what you could actually do instead of hard coding the things that you want to flip on and off, you can write some code where you pass a parent object to it, and it reads out the list of widgets from the parent object and then loops over those. And you can make this a lot more dynamic. It gets a little tricky when you have nested frames and all that because you can't disable a frame. You could have to disable what's inside the frame. But if you've got some pretty basic things there, you could just pass all the individual frames that you want to disable to it, and then it'll loop through all of them and then gray everything out. All right. So here we are. And which one is this? Oh, yeah, this is my pop-up. So the loading frame. This draws a loading bar on the screen after they are done selecting files and they're going to upload them. You can see that this code looks just like the main one, and really you're going to see that if you're doing anything involving multiple windows, the code is going to look basically the same across them. There is another option called TK top level, which is a really great option for when you're creating another window. In this case, we're going to be drawing a frame on top of our original frame. So we're getting back to, I think, what you mentioned about, or who was that? Who was it that asked about placing stuff on top of each other? So there's a little trick in here that we're using for that. All right, so we're initializing it. Its parent is also the root TK object, and we need that, and I'll explain why in just a minute here. And this is the one exception that I mentioned. I am using TTK in this option because the progress bar is a themed widget. It's not available in standard Tkinter, so we are using TTK in order to draw our progress bar. And that's what this does. This actually overlays a progress bar on top of the screen after they click OK. In this case, I'm actually doing determinant, and I'm using the method where I control the progress of the progress bar as I'm executing actions. In this case, and the length is in pixels, by the way. When I say length 250, that's in pixels. So right here, on that object, progress, I'm setting the initial value to 0, which might be redundant. It might already be 0 by default, whatever. But I'm also setting the maximum equal to a variable called count. And in the main code, what I'm doing here is I'm taking, after they choose all their files, that's all gathered up as a tuple assigned to a class attribute. When this gets called, we're going to see in the next slide, I'm actually taking the length of that tuple and passing it over. So the maximum value for our progress bar is going to be equal to the number of files that we're processing. And here is where the magic happens. And, oh, nope, I forgot something. So how exactly am I overlaying a frame on top of another frame? Well, a little bit higher up in there, and I was missing a box on that one too. Shame on me. You can see self-grid. Grid. So I actually skipped over this during the passive prompt example. My bad. Earlier I had said don't mix pack and grid or else you're going to have a bad time. That's if you're mixing pack and grid within the same container. You can actually mix and match them to great effect if you are packing frames or gridding frames and then packing widgets inside them, or you're packing a frame and you're gridding widgets inside the frame. Because when it gets down to placement, the frames are individuals. You know, they don't share the internal placement of their widgets with other widgets. They're self-contained. So you can have one frame on the screen, like say you had a box of 4 frames on your screen. It's like you're going to put widgets in this one, so on and so forth. You can grid out widgets in the first one, in the first frame, because you want them to be specifically placed. But then you can pack widgets into the next one because you don't really care about it. You just want them sequentially listed top down. And you don't need to grid all that crap. You just pack them because they'll go top down. In our password prompt, I was actually gridding out the labels for username and password and the 2 entry boxes. So that frame was packed on top of our button frame and below the message widget. But inside that frame, it was actually, the first label was grid 0, 0. The second label was grid 0, 1. The first entry box was 1, 1, and the second entry box, or 0, 1, and the second entry box was 1, 1. You know, it actually makes it really easy when it comes to sitting down and designing your GUIs at first, because you can literally just draw a basic thing on a sheet of paper, and you could be like, well, I'm going to pack them all, so I've got, you know, kind of like Bootstrap, you know. You're going to pack it all, so you got frame, frame, frame all in a row. But then you can start drawing lines on the inside, being like, and this is how I'm going to grid out this one. And then you just do 0, indexing starting at 0 and onwards. It makes it really easy to plot out how you're going to array your widgets, and then you just pack them and grid them. All right, so now we're going to continue on to the submit function, because I did forget about that. So this is how you pull out whatever it is that they put into the text field. And earlier I had mentioned how the comment, the text widget was actually really powerful. Well, when you're pulling stuff out of it, you're actually doing so by telling it you want to pull out the contents of the text widget starting at this character spot, and then you specify where you want it to end. So first character spot, all the way to an end is just a shortcut word for the very last character in that, so you don't have to know what it is. you can do crazy things with this because there are some really cool advanced examples out there of Tkinter, really simple Tkinter applications, which are actually pretty basic text editors, because you can actually pull out stuff according to text selections, and you just grab the cursor positions, and then you calculate out how many characters it is, and then you're pulling chunks of code out. And there's a lot that you can really do with this widget, and I'm just using it for the absolute most basic thing there is, which is I'm just grabbing all the text. Oh, there we go. So right here, if comment rstrip. Rstrip is just to remove some extraneous return characters. They're always at the end of this thing. It's kind of annoying. There's 2 return characters at the end of it every time you just grab everything. So rstrip just peels those out. So I'm just checking to see if there's anything in the comment field, and then if there is, I'm going to do something with it. In this example, I'm just printing it because you can see it on the command line if you're running this example. If I was doing something like, say, submitting a form or submitting a ticket or adding a comment to a file that was being uploaded, I could assign this text to another variable and then pass that on to whatever else I was doing for the logic. Now, if we get a little further down, this is where we start getting into that file list, because they did choose files, they selected however many files, and then they hit OK. So if they selected any files, because there's go back a little bit, you see if selected files, if a tuple is empty, it returns as false. So in here, this is where the magic starts happening. So we are calling the loading frame right there, and that's all there is to it. And I'm assigning it to a variable because I need to be able to kill it after I'm done with it. We don't want the frame to just stay on the screen. We want to get rid of it when we're done. So I'm creating it. I'm passing in the master for our application as its parent. And I'm also passing in that length count of the selected file. So that way that's going to set what the maximum for our progress bars are going to be. Then right under that, yes. Then I'm calling that state toggle function because I'm disabling everything in the background. You can't interact with it anymore while the loading bar is on the screen. Now we move on, and this is where we're doing the stuff with the file paths. Now the shortcut to this could have just been I open up all the files, because then I would avoid a race condition, because I might have grabbed the paths and then between the time where they clicked choose files and hit OK, something could have potentially happened to those files. It's possible. But in this case, I'm taking all the file paths, and see right there, loading progress plus equals 1. I'm actually incrementing the loading bar by 1 as I go to process the first file. Then I'm calling update, because sometimes you run into something where with certain widgets, they don't just dynamically render themselves when you make a change. So you call update on that widget, and then it will actually render with the changes. And in this case, we're telling the parent window to update. Then right after that, I'm printing out what file it is, like file 1 of however many, just on the command line. Could be also put into a logging function. And then after that, I have an artificial sleep counter in there, because if we didn't have any, because we're not actually doing any uploads right now, it's just an example. This would complete immediately if you clicked OK, because it's just running through a bunch of file paths. So there's a sleep timer in there just to give it some padding. And then with open, the path, because we're doing for path in our selected files, it's just going to open up that file. It's going to print out the file object just to prove that it actually is opening up a file you selected. And then it'll continue the loop to the next one, in which it will increment the progress bar by 1. You'll see the progress bar progress. It'll perform the actions on the file and continue on until it's actually done exhausting all the selected files. Then at the very end, when that's all done, we destroy the frame that had the loading bar. And like the same exact thing on our root window, our cancel button calls master.destroy. If you want to destroy any widget that's on your screen, you just call the destroy method on it. So you can also dynamically take away widgets too, like we're doing here. And then we call our toggle function again. We say normal, so everything goes back to normal. And then we get a little movie that shows how this whole thing works. Hello, Mac admins. See that sheet style rendering right there that you can only do with the dialogues and really ticks me off? And you click OK, the whole background gets grayed out, and you see the loading bar as it progresses through each one of those files. And you have to remember there's a 2-second sleep timer in there to artificially drag this out. And then when it's done, it goes right back to normal. I could have added something in there also to clear out the variables and clear out the text box and all that, but I just sort of left it there. So, if you are interested in more, these are the resources that I have relied upon. Right at the top there, the docs. Read the docs. I'm pretty sure I haven't seen a single Python-related presentation where at some point they didn't tell the audience to go read the docs. But this is where the Tkinter library docs are for Python. And I'm pointing to the version 2 ones because until Apple loads Python 3 onto their systems, we shouldn't care about 3. So, Stack Overflow, this link right here is just for the Tkinter tag. Now remember, Tkinter is multi-platform and multi-language, which means Tkinter gets used in Ruby. It gets used in Perl. God forgive you if you use Perl. But it gets used everywhere. So just going to that tag means you might get a lot of references to a lot of different languages. But it's a universal toolkit, so even if you can't find the answer specific to Python, you might actually find something similar for Ruby or Perl or whatever. Or just the basic TCL, TK syntax, because you can build these GUIs using just the toolkit with no other program. FBot, don't understand why it's called FBot, but these are the old docs. But there's still a lot of good stuff in there. Underneath them are TK docs, and those are the new docs. So both of those, excellent resources. And that's all I've got for you. Thank you for coming and listening to me drawl on about code for about an hour. And if you really want to, I can try to pretend to answer your questions. All right, we're going to try this. Secure your drinks. Yes.
Just real quick, you mentioned the drop-downs have the custom Python icon. Can you package or build in an icon and point to it? Is it possible, or no? Because we push out an icon, so it's already on my system, so I could point to it.
You could try replacing the default icon bundle in the Python launcher. If you're really going to go down that route, you might as well just deploy your own copy of the launcher and leave the system one alone. Okay. Would be my recommendation. Of course, then we're getting into the realm of the pre-deploying things or the scripts. But even if you are pre-deploying some things, there's still a lot of power in here for being able to dynamically generate stuff. Anyone else? There is no way I was that thorough. There we go. Brad wants to troll me a little bit, so let's let him troll me.
No, I don't have anything to troll you on. So if I were to add another frame, so I have screen number 1, ask a series of questions, screen number 2, ask a series of questions, screen number 3, how would I structure screen 2 and screen 3? With the idea of I have this class, I have this frame, how can I move between those?
Well, I'm batting 0 for 2 right now because, once again, I didn't really answer the point that he brought up. How was I overlaying that widget? I'm gridding it. So in this example, if you guys go look at the code for the file uploader, you'll see that the root frame, the app frame, it's not being packed. It's actually being gridded at 0, 0. And then when I'm packing this frame, this one's sized much smaller, and I'm disabling everything in the background. But I'm gridding that at 0, 0 as well. So it's centering it onto the existing grid of the root. What you can do is you can create a switcher. There are 2 ways to do this. You can create a switcher where you're just redrawing a frame of the exact same size on top of the other one, because there is a method on widgets and frames called raise. So if you call raise, it brings it to the forefront on the window manager. So that is one option. The other one is that inside TTK there is Notebook. Called Notebook? There is an extra option in TTK for creating tabbed views, which I didn't get into because I've never used it before, and I was already way behind on writing all this code. But there are options for it. There's this guy who has a YouTube series for various programming subjects in Python. In one of them, he goes through how to do frame switching in Tkinter. He doesn't go through a lot of the process of properly organizing the stuff because he's just showing how to get the buttons to actually raise and lower the frame so that you're interacting with the correct set of widgets. But it is a good example that you can build upon.
Thank you.
We got 10 minutes for Q&A. You guys, we can wrap up now, but I'm willing to answer more questions.
This is actually a little ridiculous and kind of based on my environment having some old stuff. What's the minimum OS target for this?
It's a good question because I know you can at least go all the way back to 10.7, and I believe you can go further than that. The versions of the toolkits will be a little bit different as time has gone on. Right now, I believe on El Cap it's TCL TK 8.5. Mm-hmm. Of course, Python is also incremented in version along with that. The core syntax is pretty much the same across all of them, though. It's just that you might be missing some bug fixes here and there, or possibly a widget. You may not have TTK on much earlier versions. I haven't tried that though. In my environment, I'm usually either at the current version of OS 10 or the version immediately behind it. So I actually don't even think about Mavericks anymore.
And for the most part, I'm in a similar situation. I just have enough machines that, yeah, there are a couple of those. So for anybody who is in the same position as I am who has to deal with old stuff, I'm pretty sure like Pashwa, if you have to, we'll throw up dialogues in older versions. But this is a lot more elegant for anything that's new. So thank you very much.
Sure. There we go. Throw that.
All right. Are you familiar with Platypus?
I am.
Okay. So you've got these scripts, and they're raw Python scripts, and you'd quickly glanced over an application to turn it into an application.
Py2app is what I use.
And it's just a wrapper?
It is not a wrapper.
Okay.
Hold on. We're going to go exploring here. If you want some basic instructions on how to use Py2app, you can go check out hip status, because at the bottom of the page here, I have all of my instructions on... Oh, for the love of God. Hold on. Where is the screen? There we go. Oh, no, full screen it. Come on. There we go. There we go. So this goes through all my instructions on how you take the source code for hip status and run it through Py2app. So you can use this as a basic starting point if you're interested in actually compiling Python code into a native OS 10 application bundle and sign it. There are signing instructions in there.
So to follow up too, you're basically running this inside the user's account, correct? Whatever.
So if you're using Monkey or the JSS and you have it execute a script on the system, that script runs as root. But the GUI.
Is there any limitations with that in terms you don't get any errors back from your Python?
Haven't yet. Well, unless there's a syntax error in my Python.
Okay.
Which that always happens.
Well, so with like Platypus, you have limitations with sudo because of Apple's security frameworks. So you can run things locally, but not.
I've known about Platypus. I've never used it. This process right here will actually either use the system Python or compile into it its own copy of Python and create an OS 10 bundle. It's a lot like what Dropbox does, because Dropbox is a Python application.
I'll follow up on that a little bit. I think what you're getting at is if the master process is spawned by root and it's in a user's GUI, you do have to do a lot of special things. Well, if the user starts it in self-service, there's no problem because the system can follow the security sockets from self-service to the script back to the user. That's not a problem. But if you want it to just pop up on the user, you have to do some special magic. And I can give somebody, okay. I need to give somebody credit, and I can't think of their name, wrote a brilliant article on this, and I can share it with you. I wish I could credit that person right now. I just can't.
Yeah, okay. I was misunderstanding what you were asking there. Yeah, in my case, all my GUI stuff is executed from self-service, so the monitoring process triggers the policy, which runs the script as root. So I can do pretty much whatever I want from the GUI at that point.
And Bryson, I'll troll you for a second if
Please
you want. So if you know all this stuff and you work for Jamf, why can't Jamf paying customers have like a better Jamf helper to do all this stuff?
You understand they're going to be watching this, and I'm going to get a glare when I come back now. Actually, there was not enough time, but for a hackathon project, I was thinking about building sort of a Python version of this dynamically generate GUIs that you could make extensible. I found out though, and you guys need to check it out. I'm going to call him out. Mikey Frogor is over there building something similar to that, where you can actually take a nib file from Xcode, pass it into a Python script, and have it build out a GUI for you. So that I'm going to be looking forward to checking that out, because it's actually a library, so you can either execute the library or import it into a script. That'll be really cool to see. But no, like you can do a lot of stuff, with these, and it's like packing, gridding. They're actually really easy concepts. So it wouldn't be a whole lot of work to get started on making some sort of tool where you pass it some arguments or you pass it a configuration, and it just pops up a GUI of what you asked for. Oh, you had to bring up Jamf Helper. All right, I think, no, he's good now. He really wants to throw that box, and we've got 4 minutes. Do we have one more to fill up those 4 minutes? All right.
Is there another GUI? Are there other GUI? I'm not getting the right word. Classes, whatever, in Python besides Tkinter that you played with?
Third-party ones, and there's actually a good selection of them.
Deploy them then.
Yeah, they're third-party libraries, but yes, there are other options if you want to go down the Python route of building Python GUI applications. You don't have to use Tkinter if you don't have to rely upon standard library. In my example, everything was standard library. There was nothing you had to preload. You didn't have to use pip to install packages or anything. This was entirely standard library, which goes with the theme of you can deploy a GUI without having to do any sort of pre-deployment of things like Cocoa Dialog. If you want to go down the rabbit hole and the other way, you could extend Tkinter like crazy with add-on packages like Pillow, so that you can Pillow, so that you can actually then import non-GIF images into it, because the standard library only supports GIFs. So when you were seeing that iPhone application up on the screen, it was downloading GIFs that I had already pre-converted, because that's what it supports out of the box. But there are add-on libraries which add support for the whole gamut of file types for rendering within the application. So if you want to go a third-party library route and with what you're building, and you want to stick with Python, sky's the limit. Pretty much like with anything else with Python, there's a library for it. If we got no more, thanks.